You know that our goal for today's lesson is to work with the identities now. So now that you went ahead and took some time to memorize those identities, and now that you know a little bit about where they come from, we're actually going to solve for some trig function values. So we're going to go ahead and do example 1. And there it is. Sorry for the poor slideshow quality. The file got corrupted somehow. So I had to screen capture from my document camera the actual piece of paper. So this isn't from the Word document. Oh, so annoying. So I apologize for the not great visual quality there. But in example 1, there is some important wording I think that you need to be aware of. You know, it's pretty rare that I type extra information in a problem that isn't needed. Quite honestly, I don't. I'm not out to trick you. I just want to make sure you can do a problem. So there's some wording that we're not going to pay attention to really until the end of the problem, but I'm going to highlight it because you can't ignore that it's there. And the wording is, let theta be an acute angle. So let's just talk about that for a second. If theta is an acute angle, do you remember what acute means? What does that mean? Go ahead, Richard. It means small. How small? Yes, not negative though, because we do have negative angles in trig class. So it's got to be between 0 and 90 degrees, or what in radians? Do you know, Adam Bauer? Acute angle. Yeah, between 0 and pi over 2. Very good. So those are acute angles. You want to kind of keep an eye out for those. Now, in this case, they're telling us, let theta be an acute angle such that the sine of theta is 0.6. And we're supposed to find the values using your trigonometric identities. So I'm going to teach you this step by step. Step 1. Step 1. You have to choose an identity to work with. Here's how you're going to make your decision, because there's several boxes of identities that we just filled in as our warm-up for today. You're going to choose an identity that relates. Choose an identity that relates. That's not how you spell relates either. Try that again. Relates. What you know to what you don't. So in this case, they did give us a piece of information. They told us that the sine of theta is 0.6. And then what we don't know right now is what the value of the cosine of theta is. So carefully look at your charts, or dig in your memory even better. You have to pick an identity that relates sine and cosine. And to be very honest with you, there are 2 that my students typically throw at me right now. So I'm going to ask you, what identities do you see from the warm-up that relate the known to the unknown? What identities do you see that relate what you know to what you don't? What identities have sine and cosine in them? Because sine is what we know. Cosine is what we don't. Go ahead, Adam. The Pythagorean one. Which Pythagorean one? The first one. So that's one of them. There's another one that relates sine and cosine together. Go, Michael. Yeah, quotient identities. So we'll just start with tangent. You know that tangent is sine theta over cosine theta. Okay. So keep in mind, my mission is to solve for cosine. Right now, cosine is behaving like x in my brain because I don't know what it is. So I assign it a variable. Call it x if you want. Now, what's important to understand is that in any good algebra problem, when you're given one unknown, that can be the only unknown in the equation. So here's what I'm trying to say. Like, what I'm trying to say is that one of these identities is better to use than the others. You can't solve one equation if it has more than one unknown in it. So let's entertain for a second this first identity. Sine squared theta plus cosine squared theta equals 1. I know what sine is. I don't know what cosine is. And then that's equal to 1, which I know what that is. It's 1. If I use tangent, I don't know what tangent is. I don't know what cosine is, but I do know what sine is. So one of these is better than the other. This one would have 2 unknowns, so I can't use it right now. That makes me use sine squared theta plus cosine squared theta equals 1. I can now use that identity to solve for cosine. So that's what I'm going to go ahead and do. I'm going to use my algebra skills to solve for the missing value. So in step 2, you're going to use the identity to solve for the missing value. And I'm going to give you a disclaimer. You got to watch your signs, and I don't mean S-I-N. I mean your positives and negatives. I highlighted that piece of information in the beginning of the problem for a reason. So in step 2, I'm going to use my identity to solve for the missing value. The identity that I chose, once again, was sine squared theta plus cosine squared theta equals 1. So I know that the sine in this particular equation, the sine of theta is 0.6. So I have to sub in 0.6 for sine. So sine squared theta is going to be 0.6 squared. I don't know what cosine squared theta is. I'm trying to solve for cosine right now. And then this is all equal to 1. Can anybody tell me what I would need to do first in order to start to solve for cosine? I need to solve for cosine like it's x. What do I do first? Do I add a b? Yeah, how do I do that? Do you know what 0.6 squared is? It's just 0.36, because 6 squared is 36. So this is 0.36 plus cosine squared theta equals 1. And you'd get this by itself. Do you know what you would have to do? Yeah, subtract 0.36 from both sides. So that does get you cosine squared theta all by itself. You would just do 1 minus 0.36. That's 0.64. Although I was asked to solve for cosine in this problem, but right now I have cosine squared. So how do I get rid of the squared? Adam. Yeah, just square root both sides. Remember from your college algebra class that whenever you square root both sides, you have to include something in front. Do you remember what it is? Good. So we get plus or minus 0.84 because the square root of 64 is 8. Square root of 0.64 is just going to be 0.8. So with that, I'm like, oh, I can't have 2 answers. So I have to go back to this whole idea about theta being an acute angle. If theta is an acute angle, we're talking about theta being in quadrant 1. I think it was, I forget who said, it's got to be between 0 and 90, and then Adam Bauer said it was got to be between 0 and pi over 2. So we have to think, if we're talking about quadrant 1, is cosine positive or negative in quadrant 1? In other words, are your x-coordinates positive or negative in quadrant 1? Positive. So this negative sign shouldn't even be there. My answer for the cosine of theta is positive 0.8, because this means that our angle had to be in quadrant 1. In other words, it had to be an acute angle. If they didn't have that, it's called a constraint on our answer. If that part of the problem wasn't there, you could honestly leave both answers there. Cosine could be positive 0.8 or it could have been negative 0.8. But because they put that very specific wording up there that I highlighted in yellow, you actually have to like be restrictive of your answer. Again, this is what we call a constraint. Okay, so part B. We're going to repeat our steps. Part B. I have to find an identity that relates what I know to what I don't. Well, right now, because it's part B, I know two things. I know sine and I know cosine for whatever this angle is. So I know sine and cosine, and I need to find tangent. So I need somebody to pick an identity that relates for me, tangent, sine, and cosine. Tangent, sine, and cosine. Michael. Yep, tangent quotient identity. Quotient identity for tangent says that the tangent of theta must equal the sine of theta over the cosine of theta. Now, I have a question. I have something I need to point out to you at this point in time. Okay, next week we're having our first really big test. Do you see how bad of a position you could put yourself in if you don't know the identities? You can't even start the problem to solve for x. So again, just to reemphasize to you how important it is, when I say memorize something, you have to. There's no way you could do these problems if you didn't know the identities. Same thing with the unit circle. You know, if I ask you to find the, tangent of 135 degrees, you're not allowed to use a calculator. Well, you got to know those coordinates so that you can divide out your y over your x. So please, make sure you know your unit circle before next week, and make sure you know your identities. So you're toast if you don't even know the identities. All right, so yeah, Michael, good job. The tangent of theta is, for our quotient identity, the ratio of the sine and the cosine. So from our given information in the problem, we know that the sine of theta is 0.6. And from our hard work in part A, we know that the cosine of theta is positive 0.8. 0.6 out of 0.8, which is 3/4, right? 0.75. So that's the value for tangent for this angle. Are there questions about that? All right, let's do it again. Example 2. This time around, you're asked to let theta be an acute angle. So once again, we have that constraint. We have to be in quadrant 1. We can let theta be an acute angle such that the tangent of theta is 3. And we're supposed to find the values of each of the following by using our trig identities. So in part A, it says find cotangent. So now you have to decide on an identity based on the fact that we're given the tangent is 3 and we're asked to find cotangent. So which identity is going to relate tangent to cotangent? Is it a Pythagorean? Is it a quotient? Is it a reciprocal? What do you think, Joey? Do you see it? What relates tangent and cotangent? Which one has tan and cot in it? Did you get them right when you did the warm-up? You're on the right page, I'll give you that. Which one do you see has tan and cotangent in it? Tan theta and cotangent theta. Sorry, I put you on the spot. Anybody want to help Joey? Oh, did you find it? Oh, okay. You could do cofunctions, but unfortunately they just don't tell us anything about the angles. So they don't tell us, hey, these thetas are complementary. You can only use cofunctions if we were asked to find like the sine of 30, but we're given the cosine of 60. Or the sine of 45, and that we're asked to find the cosine of 45. So they have to be like complementary. It's a good thought though, because they're on the same line. It does have tan and cot in it. So we're brainstorming right now. I'm going to write Michael's down. He said the cotangent theta is equal to the tangent of 90 minus theta, which is true. It doesn't quite work, though, because we don't know, our values for these. We don't know that our thetas are necessarily complementary. So we can't use that one. What do you think, Troy? That sounds great. So for instance, I know that cotangent of theta is equal to 1 over the tangent of theta. That is true. In other words, I could just flip tangent to find cotangent. And they do give you information about tangent in the problem. They say, hey, tan is 3. So I can replace that tan of theta with 3 because it's equivalent. So the answer to this problem is just 1/3. That's it. So you see how, sometimes it can be easy. The algebra gamut we run is pretty broad. It just ranges from simple substitution to solving an exponential equation, a radical equation. Solving an equation with a radical. Now we have to find secant theta. Please keep in mind that I now know the tangent of theta, the cotangent of theta, and the secant of theta. So you could pick a couple. Oh, I see Shayla writing. What did you pick? Did you pick one? Which one did you pick? Which one? Perfect. So 1 plus the tan squared theta equals secant squared theta. So this related something that I know, tangent, to something that I don't, secant. It had them both in there. Do you see that? That's why she chose that. Okay, now I'm going to substitute what I know into the problem. So substituting what I know into the problem, I know that the tangent of theta is 3. So again, I'm going to work with the tangent of theta, and the tangent of theta is 3. Careful though, we want tangent squared theta in this identity. So we're going to do 1 plus 3 squared, not just 3, equals secant squared theta. So 3 squared, I'm going to simplify that. That's 1 plus 9 equals secant squared theta. In other words, 10 equals secant squared theta. And then I have to square root both sides to get rid of that squared. Now the secant of theta is equal to plus or minus the square root of 10. Please keep in mind that we're still dealing in quadrant 1. In quadrant 1, everything's positive. X's are positive, Y's are positive, everything's positive. So in this case, we can get rid of the minus sign again. So the secant of theta is the square root of 10. What's up? You can leave it like that. Leave your answer exact, that's fine. You want to simplify the radical, however. So if this were the square root of 20, you would want to break that down to 2 root 5. Okay, I'm going to show you a trick real quick. What's up, Adam? Okay, so for this lesson, it's really not that big of a deal. It's pretty much always going to be positive, even throughout your homework, because that phrase, let theta be an acute angle, is in there. But as we move through the course, that constraint changes. It could say, let theta be between pi over 2 and pi. It could say, let theta be in the 4th quadrant. That constraint's going to change as we get harder and harder and harder with our problems. So this is a nice segue. I wanted to show you a trick. Now, ultimately, pluses and minuses for me are always minus a point. Ultimately, if you can pick out an identity and solve for the missing value, that's really what I need from you. The plus or minus, I usually just do -1. Now, let me show you a trick to guarantee that it's always going to work out for you. And I'm going to do this trick more than one time this semester. This is just the first time you're seeing it. You can draw it like on the back of your notes, or, I know I didn't make this like a special space, but I did want to show it to you to have you think about it. It's a really nice little shortcut. Okay, just a little bit of background information. These are the quadrants. Right now I'm talking about quadrants 1, quadrants 2, quadrants 3, and quadrants 4. And if you were paying attention to Adam's very, very good question, you know that the sign, the plus or the minus, is going to matter. So let's talk about plus and minuses as they pertain to the quadrants. For instance, I know in quadrant 1, I go over and up to get in it, which means that my x's are positive and my y's are positive. So as far as my coordinates are concerned, x is positive, y is positive. In quadrant 2, please keep in mind, x's are negative, but y's are still positive. Oops, I just wrote y. X's are negative, but y's are still positive because you go to the negative x-axis, but you still go up to get into quadrant 2. To land somewhere in quadrant 3, you go to the left and down. So those are all negative there. Kind of looks like a face with a nose. And then in quadrant 4, you go to the right. So that's positive, but then you come down to get into quadrant 4. Please recall that these coordinates are also cosine and sine in disguise. Do you remember that? So cosine is always your x value. Sine is always your y value. So if you want to think about your coordinates this way, you know sine and cosine are both positive in quadrant 1. In quadrant 2, cosine is negative, but sine is positive. In quadrant 3, sine is negative, cosine is negative. And in quadrant 4, cosine is positive while sine is negative. Now that all gets very confusing when you're asked, okay, what is sine of this, cosine of that, tan of this, secant of that? That gets a little bit confusing. So I have this little mnemonic device. All students take classes. We heard that? Maybe? All students take classes. ASTC, or my first name, Stephanie. So you could abbreviate all Stephanies take your chocolate. It's true. I will. Don't test me. So all students take your classes, however you want to remember it. Horrible error. Here's what that means, by the way. All 6 of our trig functions are positive in quadrant 1. Sine, cosine, tangent, secant, cosecant, cotangent, all of them are positive in quadrant 1. S stands for functions associated with sine, which means sine and cosecant are positive in quadrant 2. And it makes sense because our y values were positive in quadrant 2. So this stands for all. All 6 trig functions are positive in quadrant 1. In quadrant 2, all trig functions associated with sine, which means sine and its reciprocal function, cosecant, are positive in quadrant 2. All students take. T stands for tangent. In quadrant 3, tangent's positive because you're dividing a negative by a negative. Negative y over negative x, that's positive. So functions associated with tangent, in other words, tangent and cotangent, are positive in quadrant 3. And lastly, in quadrant 4, notice your x values are positive. Since your x values are positive and cosine is x, all of your functions associated with cosine, what I mean by all is cosine and secant, are then positive in quadrant 4. So that's a little way you could sort out the signs. All students take classes. A little tip. I will do that again, probably even next week. Okay, questions about that? I did want to draw your attention just briefly to your homework.